of the ocean-based industry in 2010 by industry, and the other one is that forecast for 2030. And what we see, for example, offshore oil and gas is to have a smaller share. On the other hand, offshore wind is expected to grow. We see industrial fish processing to grow from 5% to 9%. So all of that is a little bit what we expect. But where is the data and information aspect in all of this? Well, data and information is growing in importance, and it drives a need for further observations. And the traditional blue economies that we see here to the right, or we see them also here depicted in this blue bubble to the bottom left, like tourism, transport, port activities, oil and gas, offshore energy, etc. Well, there is observing technology leading and supporting those. But there will be a point in time where those observing technologies and the whole observing market might be mature enough to establish itself as standalone. One way to consider that is through the new blue economy term. The new blue economy being an economy that delivers information that benefits the other sectors. Another term to express this type of new economy is the ocean enterprise. And the ocean enterprise is, as we see here in that table, comprising public, private, and academic entities, all of them which provide infrastructure for ocean observing, conduct measurements, help with forecasting, or deliver any services in that context. And the ocean enterprise is already growing, and it is fairly established. We see that in that study for the US, for example, it covers at the moment 7 billion. Yet it might not be significant enough, but we are getting there. Here we see an illustration of the ocean observing value chain. The ocean observing value chain is best interpreted by looking at the top right. End users and societal services are end user and societal services and benefits are generated to meet the needs and requirements related to the ocean by end users. But how can we achieve those services and benefits that are needed by the end users? Well, first we need observing technology, use that technology to conduct observations, produce data, and then derive information from that data. And here we see the respective actors for any of these market segments. Providers and developers of technology, producers of the observations, and very importantly, the intermediaries, the entities that generate information from the data that is abundant. It's important to understand that private, public, and academic players can contribute to any of these different sectors here, and innovation is needed as well as business potential is connected to any of these segments. To add something more to it, the circle here illustrates the current estimated size of the business related to any of these segments, saying that at the moment, most business in the ocean enterprise is done by provision of observing technology. However, the arrows indicate where the largest growth potential lies, meaning that the largest growth potential is expected to be with the information delivery, being with the intermediaries that generate knowledge out of existing data. So what we can state for now is that the ocean enterprise or the new blue economy, depending on how you define it, are emerging and they hold significant economic potential. So it is crucial to mature the ocean observing environment from ancillary to critical. How can that happen? How can we elevate that market? Well, it can happen through collaborations, through partnerships, or through communication initiatives, all of which can help to help with private-public partnerships, address ambitious goals, or across the entire supply chain. One of those examples for an activity were the dialogues with industry. They resembled a significant opportunity to connect the different stakeholders and the global ocean observing system. The goal of the dialogues is and was to derive actionable recommendations for intersectoral collaboration to meet the future needs of science, society, as well as the economy to expand the ocean observing system and the information delivery services. It was organized by the Global Ocean Observing System, by the Marine Technology Society, by NOAA, and it is an endorsed decade for ocean sciences for sustainable development initiative. It was the first activity of the Global Ocean Observing System where there was direct interaction with industry, and it has recently received funding of 3.9 million by NOAA in the US to bring that market development forward. So a brief timeline on how the dialogues have developed. It all started with a background paper in 22, where we defined and looked at the environment and illustrated this value chain for the first time. Then we conducted 4 active dialogues with more than 400 international participants with reports on every of these events. And the events were targeting instrument provision at the first event, the multi-sectoral ocean architecture as the second event, the ocean information services as the third, and then an outlook event for new technology as the fourth event. After that, in June 23, we sat down and synthesized all of the remarks and comments and recommendations that were made, and we clustered them into 4 focus areas, as well as underlying categories. Without any weighting, without any judgment, we basically just summarized all the valuable contributions that were made. And by today, actually by tomorrow, there will be the official launch of the Dialogues with Industry roadmap. And the roadmap being a concrete suggestion for actionable items to move ahead. And here is a sneak preview of the roadmap output. And you can see the large circles in the middle. They represent the priority areas in which the suggested activities go. And they will help with addressing the respective challenges that are linked to it. We see that improving the marketplace is the first priority area. So that is all about public acceptance as well as impact of the ocean enterprise and the market visibility. We've got shaping the future, dealing with workforce development as well as emerging technologies. And then we see collaborations to grow and impact change. For every of these challenges, we have success indicators, we have action pathways, and we link it to existing initiatives. So that is all meant to be an inviting initiative to collaboratively establish the ocean enterprise and make it more mature. So again, how can that happen? How can we take something that is out there and make it more of a mature market? As we said, the dialogues were mostly a communication initiative, but there is more opportunities that lie in the collaborations between especially science and industry. If science and industry manage to clearly carve out and generate more economic as well as societal value, then this will initiate a process that will spur itself. It will lead to enhanced clarity in the market. It will lead to more industry attention. It will lead to more industrialized solutions, which will lead to a drop in unit price, etc., ultimately leading to more and better data available to generate more value. And this is the step that we have to take together. There is no competition on the very basic level between academia and industry, and there are distinct sectoral strengths, which is why this is a good basis for win-win initiatives. Kongsberg Discovery, where I'm working at, and especially the Ocean Science Department, develop their products and offerings through collaborations. And we also think that there is time for a change to be ambitious with regards to what projects could look like and what they could cover. Here on the last 2 slides of the presentation, just a quick understanding of what we could contribute to these type of discussions and projects. We provide quantitative acoustic sensors for a variety of tasks that can be deployed on almost any of the platforms that are currently out there, and we will hear more about in this subsequent presentations. And these sensors can detect and quantify anything from plankton over fish larvae up to individual fish or jellies. But they can also be used for the measurement, detection, and quantification of physical targets such as oceanographic layers, sediment clouds, gas bubbles, as well as marine hazards. But we do not stop with these hardware and with these sensors and with these instruments. We more and more link them with digital offerings, which is another topic of today's side event. So a digital solution like Blue Insight, that will also be mentioned later, also helps to connect between sensors and platforms to deliver value to all of the stakeholders that are out there. So let me summarize on that last slide. Ocean observation as the data as well as the related services are critical for growing the economy, the blue economy, as well as society. The maturation of the ocean enterprise has benefits for academia, for the private sector, as well as society. The dialogue with industry roadmap is out there to advance the ocean enterprise and work towards the maturation of this market. Science industry collaboration is an essential puzzle piece in that context due to the abundance of various win-win options. And finally, there is the potential in approaching significant and impactful initiatives with advanced instrument carriers based on acoustic sensors or other sensors and linking them with digital platforms. And I hope by that to have given an introduction to the other presentations that are about to follow, and I'm eagerly listening to them. Thank you very much.
Thank you, Per. It would have been nice to have you here, but the weather stopped that, so thank you very much. Interesting presentation. Now I would very much like to welcome Hanne Sagen. She's a senior researcher at Nansen Environmental Research Center, where she leads the acoustics and oceanography group. Welcome.
Thank you for the invitation. I will take you up to the Arctic, where it is less observations, but we have a lot of satellite remote sensing data. So we know about the sea ice conditions, we know that the ice have declined, but we know very little about what is going on in the interior of the ocean. So I want to take you to the next slide. So to observe, how does this one work? Ah, there it is. The greenest and biggest button. Okay, so you will see here that we have some tools to bring instruments into the ocean under the ice. You need really to put instruments there. And one of the most important tools we have is the ice-tethered platforms, which is developed by Woods Hole Oceanographic Institution. And you can see that up here, the device is going up and down, and it sends data through land, and you can assimilate these data into your ocean model, like you do in open ocean with the Argo floats. However, they are quite expensive, and you can see the distribution here. It's mostly in the Beaufort Sea, and only 2 in the Nansen and Amundsen Basin. And this is one of the important tasks in our project HIAOS, which is funded by the EU. And I will tell you more about that. But first, a small history about what we have been doing. So we have worked with the Americans to develop network of moorings carrying acoustic long-range sources to do acoustic thermometry. So it started out in, in the, how do I go back then? Well, it started out in the 1990s with the Americans. They developed a trans-Arctic system for acoustic thermometry. It was only thermometry. In the coming years, we developed regional systems with smaller sources because the first, how do I get back? There. So we developed a system where we could have 5, 6 sources, and you could do tomography. You could see how the ocean evolved. And then suddenly, or not suddenly, there was a lot of developments in Canada where they built huge sources or low-frequency sources that we could manage to have in moorings. And that was what we did in 2019, where we sent also signals across the whole Arctic basin. But this time, the moorings were equipped with a lot of instruments, like oceanographic instruments. So it is a multi-purpose system where we can measure between moorings with thermometry. So we send sound from here to there and here to, in between the moorings. And on each mooring, we also have instruments like CTDs, upward-looking sonars for sea ice measurements. We have ADCPs looking up and down. We have bottom pressure recorders. And these moorings are 4 kilometers long, and we put instruments only in the upper 1,000 meters because that is where you have the most interesting variability. Then, the next step, so what we did was to measure across the Arctic first in 2019. So we sent sound from here to there, and this is what you see here. So you will see over here you have late arrivals, which corresponds to arrivals that have gone in cold water, and the deeper ones that will show up here have gone in warmer water deeper down. So this is stepped, and this is the arrivals, and you can see the arrival time. So the later it comes in, the colder is the water. So we can separate between the warm water deeper down and the cold water further up. But this also shows that we can transmit signals over long distances. And that is what we build on now. So this is what is going out next year. It will be a underwater GPS. It will be an ocean observing system with point measurements. It will be acoustic thermometry. And we focus only on the Nansen and Amundsen basin because, as you remember, only few measurements are available from that area when it comes to oceanographic observations under the sea ice. The sea ice is monitored on daily basis, but the ocean it's very, very sparse. So if you want a digital ocean or a digital twin, you have to get more information about the ocean in the Arctic. And this is to show how much we would improve if we, instead of having 3 sources in the Nansen and Amundsen basin, and then adding on a source in the Canadian basin. So you can see you cover a much larger area, and that means that you can release your ArgoFloat or your AUV or your glider and still be able to navigate under the ice. And this is a collaboration between the EU-funded HIAUS project, and we have quite a few Norwegian partners, also Kongsberg, Naxos, Mundal, and Stinger, which is industrial partners. And they deal with different issues when it comes to get data up, because even if we have moorings out, we put them out 2 years, and then we have to recover them to get the data back. So the Americans, they have focused much more on how to get data up from the ocean. So they look at the communication between moving platforms and some buoys. Oops. That was the 3 minutes you gave me. Yeah. Can you change it, please, to one more? This one. So they look at the communication between gliders and these surface buoys so that they can communicate back to land, because that is critical. If you want the operational system, you have to get the data back in real time, and that is where I think that Kongsberg and also other industry can help us with, in addition to the Americans. And I think it is important that Europe and Norway also move towards this. Then I want to mention this new initiative by Polar Connect. They plan to have a cable across the Arctic basin. They have a vision to be ready in 2030, and this is to serve both commercial needs, to get data and information over from Europe to Asia, to ensure that you have a redundancy in communication between Europe and Asia. And you can see that there is a yellow one, which is Far North Fiber. I think they have already started. Then it is Polar Connect, which is an EU program or initiative. And you can talk to Erik Bos if you want more information about the roadmap here. And then also, I think this is a unique possibility for scientists and also industry to get data real time, all the time. And also we want to connect, and we hope that we can find technological methods to connect our mooring system to these cables, either by a cable or by having more secure or better autonomous visuals that can go and get data and go and offload data to this cable. So how do we deal with all these data? I mean, previous talk, they talked about how the digital twin and how to get data from sensors, but there will be a huge amount of different instruments, different methods. So you will have a big job to do if you want to make one system. I think for the time being, we have to deal with different data systems. And I don't see a quick fix, but I hope that the industry can help us. And just to show you how we operate, This is the acoustic source that we use. It's big, and it requires a lot of planning and a lot of work when we set it out. So it's not that easy to get observations from the ocean under the ice. So thank you.
Thank you very much, Hanne. Huge possibilities and a lot more to be done. That's good. So now it's a pleasure for me to welcome Martin Skedsmo from KSAT, Kongsberg Satellite Services. He works with oil spill and vessel detection and has a long experience from remote sensing. Welcome.
Thank you. Okay, good morning, everybody. Yeah, just waiting for my slides. Okay, so this slide could basically be the only slide that I could need to talk to. Today, we connect space and Earth, that's KSAT, but it would be boring for 10 minutes just to have a look at one slide. So I have a couple of more slides, and I thought I would just go through them, talk to them, and say something about what we do at KSAT. We've been doing this for more than 50 years. I'll walk down here so I can see the slide. This is an image, a slide taken back in 1967, where we started to talk to satellites from Tromsø. And we've been doing that for more than 50 years since then. This is a beautiful satellite image of Tromsø, where you can see on top of the island. Let's see if we have the pointer here. Here, we are located up there with around 250, 260 employees. That's our headquarters. But we also have offices in the US. We have down south in Oslo. We have several people working in Svalbard. I will get back to why. But we like to say that we're part of Norway's space capital, because in Tromsø you would also find the Polar Institute, you would find several other Kongsberg divisions, NORS, and also the university, of course. This is KSAT outside of Tromsø. So this map shows where we are located with our antennas. We are located in around 25, 26 different locations. That number keeps increasing every year. What does it look like on such a location? Something like this. This is taken from Svalbard, 78 degrees north, and this is in fact the world's largest commercial antenna park. I would take it that this picture is a couple of years old, because I think that of today we might have around 150, 160 antennas in Svalbard. And why on earth would we put a lot of antennas in Svalbard this far north? Well, this video shows why. This is just one satellite. A satellite like that is a polar orbiting satellite, meaning that it moves west with the sun. It's sun synchronous, and on every pass it takes, it has to pass over the North Pole and the South Pole. So closer to the pole, the more often we get to talk to the satellite. And when I say talk to the satellite, that basically just means that we get to send signals and receive signals from the satellite. If we had an antenna around the equator, it would be, maybe we would get to talk to the satellite twice on every single day. But here we get to talk to them on every single pass. And this is only one satellite. This is some of our workhorses. KSAT doesn't own any satellites themselves, but as we deliver services throughout our antennas all around the world to satellite owners, we also provide imagery and products based upon a huge range of different satellites with a huge range of different sensors. There's a green sign there saying in-house processing. What does that really mean? It means that we download the data on Svalbard and we are able to process the image as soon as possible, having it at the customer's desk, what we refer to as near real-time, NRT. Some cases, near real-time would be within 24 hours or 8 hours. We don't do those numbers. For us, near real-time is within 1 hour. And in most of the cases where we deliver imagery or products based upon imagery, it's down to 20, 25 minutes after an image is acquired anywhere in the world. The major workhorses here would be SAR satellites. That's synthetic aperture radar satellites, meaning radar in the way that even though if it's dark outside, even though if it's cloudy, we get the results back as we would like. We also work with a huge range of optical satellites. That would be like on your iPhone or whatever cell phone you have, but far more advanced. But then again, if you're in a plane and you want to take a beautiful picture, and if it's cloudy, you only get the clouds. With radar, we get whatever is on the ground. So this is the Arctic as we know it. And why would we use radar imagery? Well, this is the Arctic without satellites. It's pitch black. We don't get to see anything. This is the Arctic with the use or help or assistance of radar imagery, or several in fact. So what we see here, we see green dots or arrows, we see blue ones, and we see red ones. The importance of this image is that the green ones are vessels captured on a satellite image, and they're correlated with something called AIS. That's a tracking system on board a vessel that basically says something about the name of the vessel, where is it heading, where is it coming from, what kind of thing is it carrying. The blue ones could be AIS attached to fishing nets. Then the most interesting parts here would be the red ones, meaning these are objects identified as vessels on a satellite image, but they chose to turn off their AIS because they don't want any of you guys to know that they're up there. So some of them do illegal fishing, and in other areas of the world it could be other kinds of illegal activity at seas. This is what we do on the oil spill side outside of Norway. So if you want to do oil and gas exploration outside of Norway, it's mandatory for you to prove that you do this in the best possible way. So every single year at KSAT, we analyze more than 4,000 images, sending out between 10 to 12 reports every day to NOFO and the Coastal Administration. If we see an oil spill, that's being reported back to NOFO, and they take care of it. This is our services on the EO side, the Earth observation side. The largest division on KSAT would be the antenna and all the maintenance of the antennas and the products and services from that side. But as we talked with so many satellites and different kinds of sensors, we're also able to provide lots of really good products and services. So just for the maritime surveillance side, we do vessel detection, oil, and also ice monitoring. On the more of environmental monitoring, it would be fisheries. We can actually detect greenhouse gases, methane and CO2 with sensors from satellites. And we can also monitor algae bloom, which would be beneficial for aquaculture farms to know what's heading their way. On land, we do several things. It could be change detections like flooding. It could be down to millimeter scale for INSAR, where we monitor several places all around the world. Pipeline, forestry. I'm going to say some words about forestry, I think, in a couple of slides. This is a typical year at KSAT. This is just a snapshot of what we do on the oceans. So we have a look at more than 70,000 scenes. We detect more than 10,000 oil spill around the world. Luckily not on the Norwegian continental shelf, but we see lots of oil spill other places as well. And we do more than 5 million vessel detections. Just going to round off with a couple of slides. So to introduce my colleague that would be in the panel on behalf of the PhilLab. But we do lots of stuff also on R&D research. So I guess that some of you know the term research-based innovation centers, SFI. So we've been part of one of those, SURFA, for 8 years. It was ended now in December 2023. But a really good initiative that we were a partner of together with university and other industrial partner. This is funded by the Research Council of Norway. Today we are working with something called Visual Intelligence with several other partners. Their main focus is AI machine learning, where their PhDs use data sets from KSAT, both on vessel and oil, to make even better algorithms and better software for our products and services. We are also a co-owner of something called the Earth Observation Center Jobs in Tromsø, together with the municipality of Tromsø and the university. Their goal is basically to try and hold the focus on everything that goes on in the city of Tromsø within remote sensing, make it easier for researchers, students to get to market. And one of the things they're pretty heavily involved in now, together with KSAT, is what is going to be discussed in the panel by my colleague Jan Petter, the PhilLab. This is a ESA, European Space Agency-driven projects that focus on innovations within the space industry. And the main goal is to set up a PhilLab center in Tromsø for this purpose. And I think that's all the time I had. So thank you.
Thank you so much, Martin. We're so proud of having you in Tromsø. KSAT. Now it's my pleasure to welcome Geir Huse from the Institute of Marine Research. He's a research director for the Marine Ecosystems and Resources Department. He works with important issues as stock assessment and quota recommendations. And now he will talk about how they use autonomous vehicles for that purpose. Welcome.
Thank you, Trude, and thanks for the invitation. I think this is a very interesting and timely session. I think we're witnessing actually a transformation in ocean observation, driven by innovations in mobile platforms, in connectivity, and in digitalization broadly, I think. So I'm going to talk a little bit about our plans in this field at the Institute of Marine Research. Okay, so IMR, we like to say we're one of the biggest marine research institutes in Europe, around 1,200 employees. And we have 4 core science areas. Sustainable fisheries, sustainable aquaculture, ecosystems and pressures, and safe and healthy seafood. So we cover a lot of ground thematically, and monitoring is a very important activity for us to do our research and also to provide advice related to industries like fisheries, aquaculture, and others. So this has been a big activity for us. And we have a very long, we date back to 1900, our institute. We have a long tradition, and proud tradition, I would say, in using research vessels, such as this one, Johan Hjort, on survey in Lofoten Islands. And we have now 8 research vessels in our fleet, both ocean-going like this and coastal vessels. So an example of this is a herring spawning survey that we undertake every year in February. And then we run zigzag courses like this along the coast, as you see, using the echo sounder to measure the abundance of the herring, and trawls to get the biological samples. And here you see the, can we see? Is there a pointer? Sorry. Okay. Anyway, you see the zigzag courses. You see the high density areas for herring in red, low density areas in yellow. And then we get a time series like this, where we see the relative abundance of the herring. And that again is used as input in the assessment, the stock assessment of the herring. So here you see the spawning stock biomass of the herring. You see it has been declining over years, and it's now at a level where it's getting close to the critical level that you see in horizontal line. So this is a very important time series to carry out every year, and in this fashion. Okay, so we have a a very robust monitoring activity today, I would say. However, there are clearly some challenges. One of them is that we have many surveys every year, and we revisit some areas. So we do one survey, we go back and do a different ecosystem component later in the year. So clearly very resource intensive, both in terms of ship time, in terms of personnel and fuel. So we have a rather high greenhouse gas emissions with this strategy. So the question is then, can we strengthen monitoring by adopting new technologies and survey strategies? So to address this issue, we have started a new project, a strategic project called New Monitoring Methodology, or NEMO. And this is focusing on the aim to make marine survey monitoring more efficient by implementing uncrewed platforms, new sensor, advanced survey designs, and machine learning. So really quite ambitious, but at the same time at a very practical level of trying to replace some of that monitoring capacity that is now vessel-based. So we have also some help from other projects like the SFI projects that we are running at IMR. So we start with low-hanging fruits here. So that time series with a great potential for using the new platforms are chosen. So very practical approach to that. We have 7 different work packages, and I'm going to report on just 4 of them. Very briefly here. Okay, so we have 2 commercially important crab stocks up here in the Arctic. They taste delicious, as you may know. And the way we estimate the abundance of these is using a combination of trawls, camera sledges, and pots. So it's quite a cumbersome activity. But what if we can use AUVs like we see here? So this is the AUV Munin up there. It's a Kongsberg AUV. Can we use that? Can we take pictures of the crabs and just count them like this? And clearly, you see, we can do that. These are pictures from this summer with a Munin in Porsangerfjord. So you can see them quite clearly. We even came across this pile, of live king crab. And it's known from the literature. So it's not brand new, but it's, we don't know exactly why they do that. But this is something that we came across in Porsangerfjord. So very fascinating, I would say. All right, but we have this clearly works, you can see it all. The problem with this approach is that the AUV is just 3 meters above the seabed. So you don't get a very large area coverage in this approach. So now we want to test different cameras, so that allows us to go further up from the bottom and cover a large area. Of course, these are large fjords, and if you're talking snow crab in the Barents Sea, we're talking huge areas. But this Munin also has the HISES, synthetic aperture sonar. So that can go much further up till 15 meters above the seabed, if you can use that. The problem is, we don't know, can you really see the crab on the sonar? And our instrument technicians and experts has been dealing with that. And on Friday, just before I was going to leave work, I got this image in the email. And so you can see up there, this is center stage. This is a king crab taken, possibly the first image of a king crab taken by HISES. So this is very promising and exciting techniques. Okay, so we're moving on with that. And then in work package 2, we're going to test out acoustic abundance estimation using these uncrewed surface vehicles. You see 2 examples of this. It's our homemade kayak here, still the prototype, and then this slightly more shiny product from Kongsberg, the Sounder up there. So these are on site in Hardangerfjorden on a Spratt survey last year. And you see also our research vessel, Christine Bonnevie, in the background. So one of the great advantages of these smaller USVs is that they're very quiet. Here we see the distribution of Spratt during nighttime from measured on acoustics with the kayak. And you see that the Spratt is really close to the surface. Here is the distribution measured same nights with the research vessel. And you see that the Spratt appears to be much deeper distributed. And that's because the research vessel is very noisy. It scares the Spratt sideways out of the beam and also deeper down. So they're moving downwards quickly. So it clearly shows that when you have fish really shallowly distributed, you will get a better estimate with these USVs. So we're going to test them for sand eel surveys, TOBIS, this summer in the North Sea, and also for the herring survey that I just showed previously. So this is very interesting. Okay, so every summer we go out in the waters, in our waters, to count whales on dedicated surveys. You know, Norway is hunting the minke whales, so we have to keep a tally on them. And the way we do it presently is to use whale watchers, whale observers with binoculars going out there in a standardized fashion and looking for the whale blow. And this is actually a very robust and high quality data set that you get from this. But of course it's very ship intensive and labor intensive. So in work package 3 we're going to test out using these flying drones as well as infrared sensors, which allows us to actually use this or do these observations when we are out serving for other purposes. So here you see a fin whale in Antarctica from last year, an image taken by a drone. And of course then you can also get a photo ID and you can do measurements on the whale as you see here. So that's an advantage. Okay, so finally in work package 4 we're putting things together. And we're going to develop an Armada strategy, as we call it. And this is multi-objective surveys where we use these drones, these USVs, and the AUVs together. So that allows us to count the whales, to count the fish, and the crabs together. And especially important surveys are the coastal survey in October and possibly the ecosystem survey in the Barents Sea. So then, of course, you can then put more surveys on the same platform at the same time. This also requires that we have a remote operation control center that we're setting up in Bergen, or planning to set up anyway. So that was a quick overview of our strategies. We're now acquiring 2 of these sounder platforms, as you see. So though there may be challenges ahead and setbacks, I think that the potential in this new technology is really great in terms of reducing resources, reducing emissions, and increasing quality, setting up a win-win-win scenario, possibly. And that's what we're aiming for. Thank you.
Thank you, Geir. Very interesting to follow this project. And now I'm happy to announce my colleague, Lionel Camus. He's leading our digital solutions department at Aquaplan Niva, where he's the skipper or captain of 6 gliders and drones and ROVs. And welcome.
Thanks for the title. Good morning. So I'm the last one in this session, and which is great because most of what I'm going to talk about has been very well introduced by the former speakers. But what I would like to put attention on is on the name of Aquaplan Niva, because we are a private research institute, non-profit, and in that respect as well, we operate very differently of the other partners. For instance, we don't have vessel, so we don't have offshore vessel. When we want to go offshore, we are dependent on the university or the Institute of Marine Research. So this is where this new technology that has been presented is been very instrumental for us. So to do research, so that's the ambition, of course, you know, in marine ecosystem, to do monitoring with regard to the blue economy, and Norway is very known for a lot of blue economy on the Norwegian continental shelf. And last and not least, we want to embrace the new Green Deal that Europe is pushing for. So in this talk, I will say a few words about the technology that we use in Aquaplan Niva, a couple of applications. So this is not just for, you know, research and a playground. It's really to turn the system into an operational system. And it goes back to what Pierre Fitzek was saying at the beginning. Just 2 examples of technological innovation to show you how things are going very fast in developing technology, and that gives you the possibility to develop new applications in the near future. And then last, concluding slides on the vision. So the technology, in Aquaplan, we decided to invest into this kind of small USV, like the Sailboy. We have 4. It's a Norwegian technology. It's a sailing boat, basically, fabricated in Bergen. And you can rig a lot of different type of sensors, like fish echosonder, for instance, ADCP for ocean current. And now we have as well sampler for environmental DNA. So they can go offshore for 3 months or more. And we've been successful to deploy them for a total of 800 days. So it's a very resilient platform. And then you have drones with batteries, you have ROV, you have gliders like this one, and also landers. You can place on the seafloor a lot of different instrumentation, and it's easy to deploy and recollect. So Geir Huse mentioned it, you need an ROC. We're actually ahead of you. So we have developed this remote operation center in Aquaplan Neva. It's multiple screen to allow you especially to manage your assets, stream your data, and visualize and contextualize your operation. And together with Kongsberg, we developed this Blue Insight platform. So to connect your asset over there, to manage your asset in terms of battery, directions, etc. And most to contextualize your operation. You don't want to be blind out there, right? You sit in your ROC, you're blind, but with this system, you understand what you're doing. And I will show you a couple of data for data visualization in 3D, like you have there, to understand quickly your data. So this allows you to cut your CO2 emission. You don't go on site, and you minimize risk because you don't send people on site. So some applications. The first one is basic research. It's led by Paul Renaud, that you will meet later on in the discussion panel. So it's about characterizing the polar front ecosystem. This is where Arctic water and Atlantic water meet. And together with the University of Tromsø, they went over there and they deployed a fleet of different gliders. You see 2 Sailboy and 2 Sea Gliders, in addition to what the boat was doing. And this is an example of all the tracks. I think you had 4 surveys with gliders, if I'm correct, at different time in the year. And so they were deployed at the polar front, and you can see as well some of the tracks go all the way back to Tromsø. So basically the assets were left on site to do transects, and then they came back to Tromsø to be recovered. So either with the data or we were streaming the data over the satellite. So while you have the boat, available for 7 days, your gliders can stay there for a month and collect much more data than anticipated. Recent and big activity we had in Aquaplan was to work for ConocoPhillips in the North Sea. And they were very interested in using all these assets to understand the impact of seismic activity and produce water. So they challenged us and asked us, how can you use your instrumentation to do that? So it's been a 7 years long project that we're actually terminating, and it's being reported as we speak. So I will show you just, briefly what we've done, because it's very, very thorough. But for instance, this is on this map the result of a sound propagation model. So from the seismic vessel that was there, you shoot and you see the noise intensity spreading in the North Sea and hitting the spawning ground of the haddock there. So it's approximately 100 kilometers. And of course, we want to know what is the sound level in the spawning ground. So you use the model, but you need to verify the model. Is that correct output from the model? So there we deployed, again, a glider with hydrophone, measuring a salinity temperature to understand the water characteristics on this transect. So we collected the actual sound level, and then we plotted this, where you have the in situ measurement in red and the model, and you can see that the model is overestimating, which is not a surprise. But basically, we're capable of recalibrating the model so that we can use the model and generate proper data. Another thing in terms of data contextualization and understanding how we can look at the data quickly. So this is the seismic vessel there. And this is one of the drones collecting fish data, and we are getting closer to the seismic vessel. And this is the Blue Insight portal that Kongsberg has developed together with us. So very quickly, we try to understand the data we collect and to adapt as well the deployment of the assets in a specific context. We have been as well mapping the plume, which is the produced water discharge from the platform. So it's a very dynamic discharge, and the oil industry is very interested to understand what is the fate of the plume. So we injected a fluorescent dye in the plume. We deployed 3 gliders to try to map a plume that usually we can model. And again, the intention was to detect in situ and improve the modeling to recalibrate this model. And further, again, in terms of contextualization in 3D, this is an example of a track of one glider. And you see a couple of spot box. This is where we detected at different depth and different intensity the marker of this plume. Further, trying to understand the impact of the plume, we try to show that with such gliders like the Sailboy, we deployed it for 3 months long. So it's a very long monitoring approach, especially during the bloom, from, I would say, to April until June. And we looked at the effects of this plume on zooplankton, chlorophyll, and the fish as well. And you can see the intensity of the data collection around the platform, all these data points that we have collected and analyzed, so it was ECOS on the data. And then the last example is offshore wind. As Pierre said, this is a growing business now in European waters, and Norway will soon have probably very large offshore wind industry in Utsira and other places. And currently you have a small one in Hywind Tampen. But what we did for Equinor was actually to deploy Sailboy right from Bergen. We crossed the North Sea, and then we collected data at Hywind Scotland for 1 month to understand whether there was more fish into this wind farm. And then we went back to Bergen. So again, we didn't send anyone on site. We didn't send any boat. We just used our drone to collect data. And again, you see a picture of the Blue Insight data visualization to understand how we operated and understand the data relatively quickly. And then more the future. This is a project we just acquired during Christmas. So it's going to be about using all of these assets to actually measure a biological resource, which is Calanus, which is a low-trophic organisms living in the Lofoten area, especially in the Lofoten area, but not only. So it's going to be a 3 years project. It's financed by the European GPI Ocean, and it's together with several countries. We have 5 countries there. And this is, in a nutshell, what we are going to do. So basically deploying all this instrumentation, looking for these organisms. We're going to use as well satellites. The Air Center in Portugal will test a lot of different satellite solutions like the LIDAR to quantify these organisms. And it's about mapping, looking at the bycatch, and to report back to the authorities, but also to help out the fishing industry to scout for the Calanus, so reducing CO2 emission for looking for the resource. So there will be a lot of activities in the 3 coming years on that topic. Just 2 examples on technological innovation, how this is shaping the future. Every one of you has used or heard about Starlink, the broadband satellite system. And we have recently rigged our drone with the Starlink antenna. And this was deployed at the polar front, so quite far north in the Barents Sea. And we were fully capable of streaming big data directly to the ROC. So what does that mean? That means you don't need to do any data processing on your system, or you don't need to store the data in your system. You can stream all of this data directly to the cloud in real time and do the analysis. So this is really a new feature which is very, very interesting. And then the other thing is we work a lot with plankton. So on one of our gliders, we have a plankton sensor. It's a high resolution sensor taking pictures of plankton like this. And imagine you get a lot of these pictures and you need to treat that. So manually it's very time demanding. So together with the research community working on plankton, we develop algorithm, so artificial intelligence to look at this data and to treat the data in autonomous manner. So using Starlink, you stream a lot of data, and you're gonna have a need of artificial intelligence. And last, to conclude, I see I have only 20 seconds left. Perfect. So it's very obvious there will be less crewed boat in the future. This process has already started. Probably it's not very visible yet, but if you talk to the large industry players, they are moving towards autonomous vessel. So that can mean as well, platforms where you can have sensors. So more and more autonomous systems. So on these platforms, you can rig sensors for environmental research. The boat cannot be just dedicated for, let's say, heavy industry. You can stream big data via satellites. The Starlink is one example. You have the 5G along the coast. You can use powerful cloud-based processing platforms for data handling. The Blue Insight is one example, but there are more out there. And it is very clear that artificial intelligence now will have to be the main tool for treating the data automatically. We're going to get so much data. We already have too much that we need to have very efficient tool to treat this data. Okay, that was it. Thank you very much. Good, we are on time. This is great. So Pierre Fitzek was supposed to be the moderator for the discussion, but as you heard, he's stuck in Helsinki. So I've decided to step up and to do this. So I'm calling now my colleagues on the scene. So Jan Peter Peterson from Kongsberg Satellites. Leif, you will represent Kongsberg Discovery. And I need my paper with me and my glasses. Paul Renaud, please step forward. And we have Anders Hermansson online. Can you hear us, Anders? Can you say something?
Hello, everybody. I can hear you, Jan.
Excellent, excellent. We see you, we hear you very well. I'd like each of you to give a few words to introduce yourself, please. Jan Peter, you can start.
Okay, we fixed it. My name is Jan Peter Pedersen. I'm working at Kongsberg Satellite Services, and have been working in the space domain for quite many years, and also have participated in Arctic Frontiers events like this quite many times. So it has been a very interesting presentation this morning, and I look forward to the discussion further. Thank you.
Yeah, good dag. Hello. My name is Leif Bildøy. I'm with Kongsberg Discovery. I'm a product manager of a product called Blue Insight. And first time at this conference. My background is in computer science, not so much ocean science, but good things happen when you merge sciences.
Hi, my name is Paul Renaud. I'm a research manager at Aquaplan Niva. I run some ecosystem research projects, like Lionel discussed this Polar Front project. And I'm also an adjunct professor at UNIS, so I'm coming with a couple perspectives from ecosystem research as well as education.
Yes, my name is Anders Hermansson from Equinor. I'm a researcher within environmental technology and responsible for our research activities within autonomous platforms and the use of them for environmental service. Yeah.
Okay, very good. Yes, this is working now. So we have these great people on stage with us, and Anders on the screen, and I would suggest we start a discussion with these experts, and then we can ask as well the audience if you have any question. Since, Anders, you're lucky to be with us in spite of the amazing weather we have in Tromsø, and you decided, or you get stuck in Trondheim. Let's start with you. So you represent the industry with us today, and looking at all the presentation that took place today, one of the questions that came up when discussing with you recently is how much Equinor use autonomous platforms for monitoring, and what are the key drivers to do so? What is the policy in your company?
Yeah. I think you summed it up very well in the last slide of your presentation. The key driver for us to develop autonomous sensor platforms is to bring forward vessel alternatives to do this vessel-based, and by this save cost from the vessel, and also to reduce safety risk for offshore personnel, and then to eliminate the burning of vessel fuel, and by that go low carbon. So these are the three main key drivers. I also very much liked what Geir Huse mentioned, that for some cases this actually gives us very good data, especially for the upper, say, 15 meters of the water column. The use of autonomous vessels is superior to vessel-based data collection. So, yeah, and we are about to phase it in. You mentioned the collaboration that we have, Lionel, on several projects like the Hywind Scotland project and now Hywind Tampen. So this is a development we're taking part of.
Okay, thank you very much, Anders. And none of the talk we had actually the academia that was represented, so that's why as well we have invited Paul with us. I gave a few slides about one of the projects where you use some of these platforms. And I mean, you work with UNIS, you are associate professor, you work a lot with Tromsø University as well, so you're teaching a lot, you meet students, and one of the questions that came up to our mind is, especially when we see that all of these assets that people have started to use, is how do you think, how well prepared are students, undergraduate students, to use this technology? Do they understand it? Is it part of the curriculum to learn how to use that, or are they exposed to this in some ways? What is your opinion on this?
Yeah, I think that's potentially something that's holding back the development a bit. I don't think students are prepared both with their essentials when they in their mathematics and sciences, and industry probably doesn't have a huge impact on the education curriculum, but I think that they could have some impact on that, as well as by informing students of the potential, and that in fact this is the future of a lot of industry, a lot of business, and a lot of research. I think that students who are coming to undergraduate, but especially at the master's and PhD level, they don't have much time to develop an understanding or expertise in these fields. There are some fields that are quite mature, such as satellite and uses of satellite imagery and satellite detection. But other areas, as we heard today, are just under development. And I think that the development of the interaction with ecosystem research, although Geir has mentioned some areas where things are developing quite fast, and we are using some, and I'm very excited to be part of that. I think that there needs to be more interaction between the industry and the educational institutions and the research, environmental research, because that's part of the sort of the core of blue development and sustainable development from the industry side.
Okay, thank you, Paul. Moving to Leif. Blue Insight has been mentioned many times by Hannah, myself, and IMR as well is using Blue Insight. So we see this new tool coming on the market, and Scientists are really embracing it. They seem to like it and to co-develop it with you. So how do you see the future for such a cloud-based platform that you guys are developing, not only just for us, but you are in discussion with other customers as well? So how do you shape this tool?
So let me first say a couple of words around the readiness of students. We do actually a lot of collaborations with academia. And I'd like to mention, for instance, the summer project we run every summer with students, where they not only learn about the systems, but actually drive the innovation of them further. So we see it not just as, oh, we need to train some students. We actually look at that for innovation. And then in the next round, year, maybe 2 years later, you'll find the work done by students rolling into products. There's a maturity level you need to reach, but it's pretty much a good source of innovation. In terms of the question, yes, we collaborate with academia and also industrial collaborations. We do that on purpose because community is always a bigger source for know-how. We're also not building mass market products. So we're building products for science. We engineer products, but to get the let's say the input from the users is extremely important in building products. So and here is the science community is the target market. So we really much need to work in a collaborative way.
Okay, very good, thanks. Let's move as well now to the sky. Martin gave us an excellent and very clear picture of the activity of Kongsberg satellites, and one of the slides he mentioned the PhilLab, and I know a little bit because Aquaplan is part of it as well, and so just before Christmas there was this very intensive proposal writing. Unfortunately, we wished to know whether the proposal is accepted, but I guess it takes more time. But could you give us a few words about what it is? You know, what will it bring to the Arctic community?
The PhilLab is a concept that the European Space Agency has launched quite many years back in time, and so far there has been one establishment located just outside Rome. And the objective is to position Europe's space position, strengthen the European position in space, both on the upstream side and also on the downstream side. And as you mentioned, in last year there was an opportunity and a call to the member states to propose an extension of the concept of the PhilLabs, and the technology, the space and community, and in Tromsø responded to that, and our focus was a bit different from from the other ones. While we focus on more on the application side, and particularly on how could the activities of the PhilLab benefit and cover the needs and which are specific for the Arctic, so they bring together both the space community, but also the other additional technology communities like has been mentioned here today. And I think the strength and the difference from us, our proposal is that we are focusing most on the application. So on the value chain, we are on the right hand side, while there are others PhilLabs more on the left hand side, on focus on the upstream, developing new sensors and new technologies that we eventually can utilize in our applications in the PhilLab.
Thanks a lot, Jan Peter. I'd like now to look at the audience. Please, are there any questions that you would like to address to the speakers or to the panelists? Everybody is quiet. From the speakers, Gerhuse, Hanna, if you would like as well to make a standpoint, if you would like to say something. Yeah, sure, if you would like to participate as well.
Well, I think as I said, I think there's a lot of exciting things going on, and I think you summed it up really, really nicely in your last slide, actually. So So how do we make this happen? You know, how do we make it go more quickly? I think, and how do we talk together and develop the strategy more together than singly? I think that's a good, you know, and important question. Maybe.
See, I could comment on that from the FEELab perspective, and one of the activities or the advantage of the FEELab is that it will have access or have at its disposal quite a large amount of money that are going to be spent on research projects, which are quite, tailored towards the industry and the benefits for the industry. And I think it's a good opportunity that we can link the science with the users, and also to utilize the resources that are available through that FEELab. And even though it will be physically located here in Tromsø, it's not a Tromsø unit only. It is both for the other Norwegian entities, but also for international communities to apply and work together with Norwegian entities to strengthen the technology and develop new application and new technologies that will be beneficial, particularly for the Arctic.
Yes, correct. Great ambitions and great expectations. Hanna, I saw that you took the microphone.
Yeah, I took it from Geir. So I think you have a lot of nice tools available, but most of you were talking about south of Svalbard. And for me, that is not exactly Arctic. So when do you plan to take your tools to the Arctic? We are deploying a underwater GPS this summer, out for 2 years. Does any of you think about perhaps trying to launch something in the interior Arctic?
I think it's up to you to utilize, again, coming back to the FEELab, it's up to you to utilize the opportunities that are available through the FEELab. There is no limitations that we have to keep the activities in the open ocean. If it's, of course, if there are applications or challenges that are related to the ice cold areas, you're welcome to apply for the resources that are available through these opportunities.
I don't know much about this FEELabs?
Yeah, FEELab.
FEELab.
No, but in the initial days, it was the main list has been the Tromsø community, but the Nansen Center, we have an agreement, intentional agreement with Nansen Center, so you are a partner of the same FEELab.
Well, you know, internal communication can be difficult.
We have a question in the back of the room. Hanna, if you can give the microphone. Thanks.
I'm wondering about the interrelationships with Antarctic science and the way of developing this technology faster by going pole to pole year round. Thank you.
Who would like to take this question? Paul, would you like? You've been working in Antarctica as well. No? Okay. I have, long ago, yes.
If I could have some thoughts, I think many of the challenges that that we have in the Arctic are also relevant in the Antarctica. So there is from a technological and challenging or technology utilization application, there some areas there are quite big overlaps, and while other areas are quite different. But I think in the discussions we have had, we have also mentioned that some of the problems or the challenges that we are focused on also are applicable to Antarctica and not only to the Arctic.
Leif?
So I'd just like to say that many of the challenges are similar wherever you are. So what we see is an uptake, for instance, in digital twins. So we're working in the high Arctic with you, Hanne, and a lot of that technology that is developed there is totally applicable in any other sea space. So what we see is that there can be authorities or other scientists in any other part of the world that are kind of struggling with the same thing. It's deploying sensors, extracting data, and then trying to reach the state of having knowledge having some kind of insight about that particular area, and so I think it's reusability will help on scale, which takes down costs. Because observation so far is that there's an awful lot of manual work done, and the biggest challenge is to make it scale, make it cheap enough with a high enough quality.
Okay, thanks a lot. I see it's going to be very soon time to close this session.
Lionel, can you hear me?
Yes.
Yeah, this was very exciting, and
yes.
This is me, guys. This was very exciting, and collaboration was mentioned by Gerhus as well. And I would like to make one final comment here, and I think this is something where we all have to collaborate, no matter what our sector is. And this is that we have to highlight and communicate the value that is in that data, because by only going ahead and collect more and more of that data and do some analysis here and there, this is one thing. But we need to really communicate to either customers, end users, and the entire society what real value comes with it, what real knowledge generation you can generate from it. And this is what will bring this entire endeavors more forward and lead to a more and wider applicability of all of these assets.
Thanks a lot, Pierre. And as usual, you went faster than me. You're always ahead of me. I wanted to conclude by giving the words to all the panelists to actually conclude and give in a few words, how you see things moving forward. And, please, let's start with you, Jan Peter. From your point of view, how the future is looking like, in just a few words.
I think you say what is quite unknown. I think most of the audience that Norway is in fact we have a small country, but we are becoming a big space player, and we are developing new and complementary technologies to the big countries that will probably provide complementary and additional data, which will be important to utilize in the future to solve the challenges that we have.
Thanks. And Leif?
Yeah, I think the future will be more interconnected. So it's all about integration of real-time data, of existing historic data, and so on. So I think that's we are doing good steps, everyone here on that, and it will just be a continuation of that. Richer set of platforms, richer sets of sensors, and in the end, better access to data.
Okay, Paul.
Yeah, I would say that it's time where you need a meeting like this every 6 months to fill in with the new developments. I think the development stage is sometimes going beyond the needs of the users, whether it's in industry or research, and I think that needs to be these initiatives need to be carried out, like Geir said, that there's going on in the NEMO project. And I think that it's a very exciting time to be working on this, and I think it's lots of good prospects for the future.
Anders, how the future will look like in Equinor for environmental monitoring?
I think there will be more and more use of autonomous platforms. I think generally in our industry there will be more, say, unmanned vessels, and more autonomy, more robotics, and this is an opportunity from the environmental side as well to use these platforms. And then I just want to say that I think with autonomous platforms comes more and more data, and we need sooner or later to start to develop technologies for more, say, automatic analysis of all the data, all the complex data, maybe especially for active acoustics, has been mentioned today by other presenters, to filter data and to make it easier to convert to knowledge.
Okay.
Not so labor intensive. Yeah.
Thanks. Geir, so you were raising, yes, to conclude?
Yeah, I agree on the last point. There's a lot of room now for doing analysis and automated analysis, machine learning, etc. But I think that another point, there's a lot of development now in the mobile platforms. And so a lot of companies and research organizations will probably purchase them. So I think that we should consider setting up some kind of mechanism where we can rent each other's mobile platforms, like a national committee that we have like for research vessels, because hopefully there will be a lot of these, and for some service you would like to have a lot of these mobile units at the same time, like the applications I showed. That will be beneficial. So I think that we should consider setting up such a mechanism to be able to rent our different mobile platforms from each other.
Very good. That's a ball to catch. I guess we have to conclude. I would like to thank all the speakers, the panelists, for this very interesting and vibrant discussion. I'd like to thank the audience for coming there today. All of us, we are available if you want to continue the discussion on a one-to-one basis. And I believe as well you can find our emails on Arctic Frontiers. So thanks a lot, and good continuation with the conference. Bye-bye.